We're going to solve this problem. A boat travels 32 miles upstream in 4 hours. Going downstream, it can travel 48 miles in the same amount of time. Find the speed of the current and the speed of the boat in still water. Okay, so what I'm going to do is let x equal the speed of the current, because that's one of the questions right here. The speed of the current. And y be the speed of the boat in still, I forgot the word, water. The speed of the boat in still water. Okay, now because it's a distance or a motion problem, we're going to use the formula d equals rt, where d stands for the distance, r stands for the rate, and t stands for the time. I'm going to make a chart where D is on the outside here using this formula, and R and T are right here. And I'm going to try to fill in, well, not down there. Oops. Try to fill in these two boxes. Okay, so what things do we have going on here? Well, we have going downstream and upstream. Okay, I can fill out the times. The times are 4. It says it travels in 4. And this one it says the same amount of time. So that's also a 4. Now the rates. Now in usual problems, the rate, when you have current or airspeed, now all the other problems you just do an x and a y here. But if I just did an x for the rate of the downstream, that is not really the rate of the downstream, and it's not what x is. If you notice, x is the speed of the current, and y is the speed of the boat in still water. So what we're doing is give you a little picture. We have a little boat. Here's my sad picture of a boat. And it's going downstream. Let's say the current is going this way. So if it's going downstream, it's going to be whatever the speed of the boat goes, plus the help of the current. This only, all other problems you put a plain x here. I'm going to say it one more time. Just the current problems and the airspeed, when they have the speed of something in still air or still water, you do it this way. Going up, say the boat's going upstream, well, it's going to be the speed of the, should have done the boat first, sorry. Let's erase this, and let's go speed of the boat plus the current. Going upstream, it's the speed of the boat, but it's going to be minus the current. This one really didn't matter, but it's this one. You want the boat first, then the current. And that makes sense because when you're going upstream, the current's going to hurt you. Okay, so then to fill out this chart, I'm going to use my formula and multiply these together to equal this. So this would be 4y plus x. And this would be 4y minus x. Okay, now when you go upstream, it tells me that, oh, this, yeah, upstream. Which one's upstream? This one. So one formula. It tells me that my upstream, this distance right here, equals 32, and my downstream, which the distance of my downstream is this, and it's also 48. 32 and 48. Okay, so now what I'm going to do is I'm going to get rid of the parentheses. And I notice if I just add those together, it's elimination. It's all set up for me where I would add them together. And what do I get here? I get 80. Or y, dividing both sides by 8, you get a 10. So y is equal to 10. Now how do you find the x? Well, we can plug it into any one of these equations. I'm going to plug it into the second one. That one looks easy. 4y plus 4x equals 48, where y is equal to 10. So that would make y is equal to 10 there. And multiplying, subtracting, and subtracting 40 is how I got that, and dividing. So it looks like the speed of the current, which is the first question, is 2 miles per hour, and the speed of the boat in still water is 10, is the Y, 10 miles per hour. And that is the answer. Hope that helps.